Just like when you're given a linear table, when you're given a linear graph, you can write an equation of the form y equals mx plus b. By the way, you know a graph is linear if it's a straight line. Yes, linear line. Straight line is a linear graph. When we're looking at tables, we generally refer to this m as the rate of change. The rate of change is how much y goes up or down when x goes up by 1. For a graph, the concept is the same, but we use a different vocabulary word. Instead of referring to the rate of change of a graph, we talk about the slope. Slope and rate of change mean exactly the same thing. How much y changes when x goes up by 1. If we look at these two diagrams, we can determine the slope of each of these lines. So we start at a particular point. We see what happens when x goes up by 1 to y. So x went up by 1, what happens to y? Y is going up by 5. This number gives me the slope, same as the rate of change. How much y goes up or down when x goes up by 1? Notice that this value is positive. When the graph goes up from left to right, y is increasing as x goes up, and our slope will be positive. Second diagram, when x goes up by 1, now y goes down by 5. Y decreases. The slope then is negative 5. When we have a line that looks like this, decreasing as we go from left to right, that's going to be a negative slope. A negative slope. As x gets bigger, y decreases. The slope is negative. Similar to the slope being a different vocabulary word with a graph, we have some different vocab for our start value. So instead of referring to the start value, sorry, that makes you not able to see it, instead of referring to the start value of a graph, you refer to the y-intercept. Here the concepts are slightly different. The y-intercept is a coordinate. It's an ordered pair. However, the x-coordinate is always 0. Every point on the y-axis has an x-coordinate of 0, and the y-intercept is just where the line crosses the y-axis, so its x-coordinate is 0. The start value then is the y-coordinate of the y-intercept. That is the value of y when x is 0. Okay, so some new vocab, but same exact form of our equation, y equals mx plus b. And you can see now where we got this term, slope-intercept form. Y equals mx plus b is slope-intercept form because our m is our slope, our b is our y-intercept. Okay, let's go ahead and look at some graphs. When we have a graph of a straight line, we need to find the slope and the y-intercept, and that will allow us to write the equation. Now to find the slope, take any point on the line, I'm going to start with this one, and make x go up by 1. So I'm going from 1 to 2, just one little notch on my grid. And now I need to see what happens to y so that I stay on my line. What happens to y? Y goes up by 2. So when x went up by 1, in order to stay on my line, y went up by 2. My slope is positive 2. Any point on this line will have the same slope. So if I start here and x goes up by 1, y goes up by 2. Just like a table needs to have a constant rate of change to be linear, a linear graph needs to have a constant slope in order to be linear. Constant slope means a straight line. Okay, let's find the y-intercept. The y-intercept is the point where the line crosses the y-axis. The x-coordinate is always 0, so what's important is the y-coordinate of the y-intercept. The y-coordinate of the y-intercept is 1 here. So I'm going to record the whole y-intercept. The y-intercept is an ordered pair, but all I care about is this 1. Remember, the start value is the value of y when x is 0. Now I have all the information that I need to write my linear equation. Y equals mx plus b. M is my slope, y equals 2. X plus b, where b is just my y-coordinate of my y-intercept. Y equals 2x plus 1. Please notice that this is a line that is increasing, that's going up. As x goes up, y gets bigger, so my slope is positive. Next example. Let's find the slope and the y-intercept. So I can start at any point on my line, see what happens when x goes up by 1. So x went up by 1. What is happening to y? Y is going down by 1, 2, 3. So when x goes up by 1, y goes down by 3. My slope is negative. This is as I would expect since the graph is decreasing. It's going down from left to right. As x gets bigger, y gets smaller. Slope of negative 3, which I could have found from any point on this line. Increase x by 1, what happens to y? It decreases by 3. Okay, now we just need the y-intercept. The y-intercept is always having a 0 for the x-coordinate. And now the y-coordinate is negative 2. The y-intercept is that ordered pair 0, negative 2, but all I care about is the negative 2 portion. Let's write the equation. Y equals negative 3. Negative 3 is my slope, x. And I could write plus negative 2. I'd say it's more common to write minus 2. Please note that if dots are not provided, you need to plot points with integer coordinates. That means points that are right on the grid. So if I hadn't already given you these points, you would have placed them yourself, looking for points on the line that exactly are on the grid, having integer coordinates.